You're listening to the Seen and Solved podcast brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to this episode of Seen and Solved. I'm your host, Tim Pennington. Today I'm joined by wastewater treatment expert Robin Deal, who's the product manager of AquaPure at Hubbard-Hall, and also with Jeremy Morgan, who's vice president of technology for bioconversion technology. So thank both of you for joining us today.
Thank you, Tim. Thank you, Jeremy, for joining us today. I wanted to introduce you to everyone, our customers and our fan base, so that we can open the conversation about bioaugmentation and how that can benefit our customers.
Great. Thank you for the invite, Robin. I appreciate it. Thank you, Tim, for having us.
So just real quick, Jeremy, you all specialize in biological wastewater treatment, right? Tell us a little bit about what you all do.
Well, basically, we offer products and services, primarily biological products for wastewater treatment. And as opposed to, your traditional physical chemical systems that basically, remove pollutants, we focus on the biological side of that. So rather than removing stuff chemically, we try to remove as much as we can biologically, which has several advantages over phys-chem type systems, primarily that we're able to remove pollutants that are dissolved rather than just colloidal or suspended. So there's a huge advantage of that. It's not as quick as phys-chem systems, but it can be much more comprehensive.
Gotcha. Well, let's start off, Robin, connecting the dots here. How is it that Hubbard-Hall works with bioconversion technology? What have you guys been working on, and how do you work together?
So we have found that a large portion of our customer base is seeing tighter limits around removal of things like biological oxygen demand, chemical oxygen demand, fat soils and greases, and nutrients, which is nitrogen and phosphorus. So while we can remove some of this chemically, a lot of times it makes much more sense and it's easier for our customers to engage bacteria, which is the biological wastewater systems. So we partnered with Bioconversion Technologies to bring a full package of wastewater treatment options to our customers who need those little extra bacteria. So while we're not powering spaceships, some of our customers may be, and they just need that little bit of extra help that bacteria can give them.
Gotcha. So you guys are working together on some projects. Sometimes you'll call them in, I guess, if you kind of need that. It's good to know when you need to ask for help, right? And they're probably the experts on that, so that's great.
Absolutely. So we use AquaPure to remove the metals, your nickel, your chrome, your zinc, your cadmium, that would kill off the bacteria. And then the bacteria come in, and they are a living organism. They do eat and consume the contaminants that we can't physically remove with chemicals. So Jeremy can talk a little bit more about how they do that.
Yeah, let me ask you, start off, Jeremy. Explain to me really what biological wastewater treatment is. Just for those who may not know, explain that to us a little bit.
Okay, so basically, primarily, it's what we refer to as a biomass. So that's a large concentration of bacteria, and it basically mimics what we already have in Mother Nature. So any stream, river, creek, what have you, there are bacteria that naturally exist there. But in a treatment plant, we kind of take that Mother Nature, what Mother Nature offers, and ramp it up to the nth degree. So a much, much, much larger concentration of bacteria. And there's really nothing that bacteria can't remove. And in fact, like Robin was mentioning, one of the concerns of Hubbard-Hall is to make sure that most metals are removed. In fact, in trace amounts, bacteria require those metals for their metabolic efforts in order to survive and sustain themselves, although in very trace amounts. In fact, a lot of systems, we actually have to back add some of those metals in the form of what we refer to as micronutrients. We kind of think of it as vitamins for bacteria.
Gotcha. So there are good bacteria. I guess I remember that from science, 8th grade science class. They're good bacteria. They do good things, right?
Exactly. They are the workhorses of actually most municipal systems.
Well, let's talk about metal finishing operations. So how does biological wastewater treatment help a metal finishing operation? Give us some of the examples of how.
So I'll start with one example me and Jeremy were at last month. We have a reman facility who brings in heavy duty equipment. They break it all down. They clean those parts. They refinish the parts and put this heavy duty equipment back together so they can go back out in the field. They discharge directly to the environment. So they have extremely low limits with a BOD of less than 10, phosphorus less than 1. And chemically, we can't do that because of all the cleaners they use and all the oils and grease and soils that are in their waste stream. So they have a bioaugmentation system that consists of a biotower, which is a 30-foot tall structure that has a honeycomb of plastic sheets in it that the bacteria live on. Then as the wastewater is physically, chemically treated, it goes through this biotower, and the bacteria lower those numbers of the BOD, the phosphorus, the nitrogen, to the point that they can safely discharge it back into the environment. Jeremy can go much more detail about what types of bacteria strains those are and how the system helps keep them alive.
Yeah, and in fact, it's not just one or two strains of bacteria that are in a community. A whole biomass community basically has thousands, if not hundreds of thousands of different bacteria strains. And most of those are naturally occurring. However, some pollutants are tougher to break down than others, particularly certain hydrocarbons. And so what we do is we take a look at that whole biomass community and we reinforce it. So we basically send in biological special forces to help break down some of those tougher nuts to crack.
SEAL Team 6, that's right. They go in and do it, yeah.
Exactly.
There you go, all right.
Just very, very, very tiny, microscopic in size. So a lot of those more difficult compounds, the only way you can really break them down are biologically and are by some really specialty strains. Now, that being said, those specialty strains are actually isolated from nature. All of our fermenters, the producers of bacteria, are called fermenters on an industrial level. And they have isolated their specialty strains from nature, basically from soil. And so once they're isolated, they're able to grow specific strains in large concentrations, and then we're able to add them to an existing biomass to reinforce its removability.
Well, it seems simple enough. I mean, it does kind of basic nature and running its course with that. But so what type of equipment is needed to run a biological wastewater treatment system?
With the biomass being a kind of a living, breathing organism, there are some specialty designs and equipment that are required. It's not as simple as having a mixed tank where we're adding a chemical and forming a flock and dropping out pollutants. With the biomass being a living, breathing organism, it does need just that. A food source, which is basically the BOD, COD that we're trying to remove, the organics. But it also needs air. So most biological systems require some sort of diffused air introduced. The bacteria still breathe and primarily breathe oxygen. Now that's in a system that we refer to as an aerobic system. There are certain systems that do not require air and run under what we refer to as anaerobic conditions. But by and large, most systems that we deal with are aerobic and do require the specialty aeration equipment to keep the biomass alive. Now, that being said, with it being a living, breathing organism, it does multiply and produce more bacteria. So eventually, we do have to remove some of that bacteria to keep the what we refer to as the age of the sludge appropriate. So there's more specialty equipment, usually a clarifier after the biomass to separate the biomass from the bulk water. And then a portion of that biomass is then wasted off to keep a consistent amount. So which is fairly similar to a lot of other physical chemical systems in solids removal. but much more critical in a biological system in order to keep the age appropriate. So those are the two primary differences between a traditional phys-chem type system and biological. You have to have the aeration equipment, and you have to have the ability to waste some of that biomass out.
Gotcha. Which is something, like you said, is facilities and shops, are constantly buying, upgrading equipment, things like that. This is something that really any shop could add if it would like to go that route, correct?
Oh, for sure, for sure. Obviously, you have to have the appropriate volume for the amount of waste stream flowing through. But we've seen systems in very, very, tiny plants, whether they're producing, say, 5,000 gallons of waste a day or 50 million gallons of waste a day. So biological systems are very, very flexible.
Right. And just curious, Robin, I mean, when you go in and you're working on a project with a customer, at what makes you, at what point do you sense that maybe using a biological treatment system should be used? Is there any kind of telltale signs or any ideas that would make you think they would be ideal for using that?
So we look at things that customers are doing. Paint stripping is extremely heavy in BOD. So we do have a couple of paint strippers who they utilize paint stripping, and then their wastewater is outside of what they're allowed to discharge BOD wise. So that's one area that we look at. Anodizers who have high phosphorus levels and need to get below 1 is another area that biologics can be used for. Remanufacturers who have FOG limits and nutrient limits and BOD limits can utilize this. So biological wastewater treatment is a growing field in our industry, which is why we partnered with Bioconversion. We wanted to be able to offer this technology as well as expertise that Jeremy brings to our customers.
Right. I was going to ask you, I mean, are many operators, shop operators, are they surprised that they can use the biological system?
I think so. I think a lot of them hit this wall of the only thing we can do, we're doing everything we can, and they're doing everything they know to do, and they're still just not hitting that lower limit. 10 years ago, metal finishers never even knew what BOD was on their discharge limit. It just wasn't there. Phosphorus wasn't there. Nitrogen wasn't there. And as we're seeing more and more areas be impacted by this nutrient loading from manufacturers, that we have to help them in some way reach these limits that they're being imposed with.
Yeah, and I guess, like I said, Jeremy, you're probably seeing more and more, not just metal finishers, maybe some other wastewater treatment facilities that are starting to adopt this wastewater, bio wastewater treatment.
Certainly. And every year the discharge limits get tighter and tighter, which overall I think is probably a good thing for the environment. But it is across the board, not just for the metal finishing industry, but for, the chemical industry, for the food processing industry, and even municipalities. Those limits get tighter and tighter every year. So, and in a lot of regards, in a lot of situations, biological treatment is the only way to reach those limits.
Right. Yeah. And like I said, a lot of facilities don't want to use a lot of heavy chemicals. They kind of want to find solutions that do not call for that. Correct. I mean, that's what it seems like it sometimes often creates more problems than solutions it provides.
For sure. And specifically, some of those limits, particularly say for nitrogen or ammonia, really the only efficient way to remove those particular compounds is biologically. There's not a good chemical solution to be able to reach those limits or reach really any removal. So biological systems are going to continue to become more and more prioritary in the future.
Gotcha. Well, that's great information. Again, I guess if people would like more information, they can reach out to Robin at Hubbard-Hall, and she would be able to put them in touch with Jeremy. But again, I appreciate you, both of you, explaining that to someone who probably never got more than an 8th grade science level here. And I certainly do understand it all. It's all coming back to me now. So I appreciate you all taking time out and explaining that to us.
Thank you, Tim.
Thank you, Tim. No problem.
The Seen in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit hubbardhall.com or wherever you get your podcast. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.